Hello and welcome to an exciting technical demonstration from Connor. I'm here to demonstrate to you the radar effect, which I have built here using nothing but HLSL. We've got no textures, no videos, no external resources. All we've got is texture coordinates, time, and some user-defined parameters. We're going to do a quick breakdown on exactly how I built this. It's purely in this custom node down here. You can see all my code down there. I've popped it out here into Visual Studio just so that is more readable for the video, because I'm aware that is tiny text. So essentially what we're doing here is we are calculating polar coordinates. We're taking the center of the grid, which was the 0, 0 positions, normally in the top left. I'm going to move that down to the middle by subtracting 0.5. And then we're using a tan2, which is a trig function, which returns us an angle. That'll give us a angle there from positive pi down to negative pi. And that is a sort of a radial gradient, which allows us to then start to draw all of the radial elements like these ticks and so on. Polar coordinates also need us to get the radius, which is just simply the length of that new vector we've created, CUV, the centered UV. So the length of that gives us our distance away from that central point. And finally, I've got just to make stuff easier later, we've got a normalized theta as well. So instead of being from negative pi to positive pi for the angle, we're going just from 0 to 1. And that's just done with a interpolation there. The marker is calculated using this little bit of code here, which is essentially just like comparing time with the angle. So we've got the fractional value of time over 5 being the length in seconds that a rotation would take, and then we compare that with the angle that we are currently at with theta, and that gives us this moving like check mark that goes all the way around the edge. Radial fade, similar idea. We're just applying the same concept across a range instead of like a narrow band there. All our contour circles, longitudinal marks, all these like grid lines, they're all working essentially the same way. They are done using sawtooth functions. So we are taking the fractional value of our radius. We are taking the absolute value then and moving stuff around so we get a sawtooth pattern instead of a sort of a factory roof situation, and then we are using some powers there to shape those curves. So instead of getting a sort of a zigzag gradient, we get a sudden drawing of a line as we move away in that distance. So at every increment, which is set here, 0.1, we get that. The outer edges, we just got a circle which is drawn to mask the very edge. And the enemy ships that you're seeing here, those are just some random trig functions which form a spiral, essentially. If we were doing this for an actual video game, you'd probably drive those enemy ships' positions, and we'd expose those, and you'd attach them to actual enemy ships, whatever AI is driving that. For the demonstration, that's just some random spirally movement that I've made. The other thing I would do if this was a commercial title is I'd be a little less purist. I would separate out the background elements, the static parts there, and I would probably attach that to a render target so we could bake it out as a texture and just store it. Because that way we don't need to run all those additional instructions for drawing the grid lines every frame. That is essentially it. One of the advantages of working purely procedurally is that the resolution is theoretically infinite. If I were to zoom in, we got all the choppy marks there from the screen filter. So if I was just to remove the screen filter there, you can see we get a perfect smooth mark at that point. If you went in far enough, you'd eventually hit floating point limitations, but I don't think you would ever need a radar that large. But in a similar fashion, you can generate these effects which are exceedingly high detail and can be blown up a very high amount. So that's one sort of strength of the system. It really wasn't that hard to make this either in terms of time, so it's a good way to quickly prototype something together in the engine without needing to open up Photoshop and draw out resources and so on. It also has the advantage that if we wanted to change the increment between grid lines or something like that, we could fairly easily do that here. Alrighty, that is what that is. I hope you found that instructional, and I shall see you in the next one.